The universe we currently reside in is comprised of three spatial dimensions: height, width, and depth. This makes our universe a three-dimensional manifold, in which objects may move about freely. To explain the phenomena of wormholes, a diagram will be used. The cube represents our universe. Let us now simplify this construct by reducing it to a two-dimensional manifold, or a plane. Objects may move freely about this plane. Suppose that two different points, A and B, were somehow connected in a three-dimensional fashion. To cross from point A to point B, an entity may now travel through this hole, crossing the distance in a significantly shorter amount of time than if it were to take the conventional route. Bumping this example back to three dimensions, notice that the mouth of the wormhole, which was a two-dimensional circle, has now become a sphere. Objects moving through one of the wormhole's mouths would remain three-dimensional, but would be moving in a spatially four-dimensional fashion. One interesting side effect of the real-life wormhole is the compression of space-time, which would grant the spherical wormhole mouth its own gravitational field. This would allow the wormhole, if regarded as an object, to interact with other gravitational bodies such as stars or planets. Suppose that we have a trough-shaped tube. If we were to fill this with a fluid, it would equalize on both sides. Enough fluid may be added to cause a slight overflow, which would hold together because of surface tension. Imagining this tube to be a wormhole, we can determine that any fluid overflow would form a sphere around the mouth. Because gases are fluids, one may conclude that wormholes may be present in our universe, but are veiled by gas. The term Jovian wormholes has been coined to describe such an astronomical object. Jovian wormholes would be nigh indistinguishable from normal Jovian planets, such as gas giants or ice giants. In other words, because gases are fluids, the mouths of the wormhole may take the form of a Jupiter and converse Jupiter. Due to data collected by the Poseidon Jovian probe, which was launched away from the public eye in 1988, some researchers believe that our local planet Neptune may present an instance of a Jovian wormhole mouth. This conclusion has, however, been met with some criticism due to a lack of data. Further research is required in the field.
Due to the termination of Project Burrowing Mole in 1991, which failed to discover any evidence of a wormhole in our solar system, the U.S. government turned their sights to other methods of anomalous transportation. Several ideas regarding teleportation were generated. The most promising was a means of duplicating an object or organism at a different location. Data would be transcribed and emitted by a self-aware neutrino-generating apparatus. The data archived in the neutrinos, which would be beamed at a special receiver, would be preserved by the nature of the particles. This information was to be read by a fabrication machine which would then physically realize the encoded objects, materializing them in a synthesizing chamber. Project Starstream was criticized for its excessive use of speculative technologies and overall unfeasibility. As a result, the project was terminated in 1997 and the employees fired.
Viewing our universe once again as a two-dimensional manifold, the existence of portals may be questioned. If our universe was to become pinched at a certain point, it would form a one-dimensional line. Note that crossing this line would produce a 33% chance of arriving at any one destination because you could end up at any of the other three planes. When converted back to a three-dimensional universe, the finite line becomes a finite two-dimensional intersection between three-dimensional regions of space. This would form an instance of a phenomena referred to as portals. Portals would appear as a presumably circular or rectangular two-dimensional film. Passing through a portal would leave you with three possible destinations. One would be traveling through the portal to, say, a different side of the planet. There you could emerge from either side of the portal. Alternatively, passing through the portal may transport you simply to behind the portal, with your location still being near the portal you attempted to enter. These portals would be categorized based on the three-dimensional spaces that they bridge. The classification intra-universal has been given to portals that connect two areas of the same universe. But this brings up the question of the existence of hypothesized different universes. represented in the displayed diagram as white, our universe may not be companionless. Other universes, presumably following the same laws of physical interaction, could hypothetically exist. If a foreign universe were to intersect with ours, then a one-dimensional overlap would still form. This would create an extra-universal portal, allowing travel between universes. Portals may in fact be an observable phenomena. A portal appearing on Earth would be associated with minor gravitational anomalies, as well as abnormal atmospheric and weather changes. They would, however, be almost completely undetectable from an electromagnetic viewpoint. One possible candidate for a portal lies in the Salina Basin of Kansas. Due to the presence of higher levels of gravity in this region, it may be assumed that a large portal exists below Earth's crust, allowing denser materials to flow in and generate more gravity. A surface-level portal candidate exists in the southern Appalachian Mountains, being situated just west of the county.